Stanford University.
Let's get started. Welcome to lecture 17 of CS 193P. We're down to the wire. We have three more lectures left. Today, we're going to talk about networking. Specifically, we're going to get into Bonjour, which is a way of discovering services online on a network. We're going to talk about NSStreams, which is a way of sending data back and forth. And we're going to talk about GameKit, which is new to 3.0. And GameKit allows you to discover and transfer data back and forth between peers. So first, some announcements. First of all, Paparazzi 4 is long past due. All your paparazzi assignments are due. Everybody's in, right? Yes? Okay, I see nods. That's good. So it's time to, you should be working on your final projects. Nobody should be outstanding on your proposals. Everybody should be approved by now, so start working hard on it. They're due on March 16th, which is 2 Tuesdays from now, 2 weeks from today, and at 11:59 p.m. And we need your code, and we need your slides. We're going to take the Wednesday to put together the slides so that you can present them on Thursday. The format, once again, is so we're going to have a big slideshow of everybody's slides, and we'll figure out the order. And you're going to stand up, I believe, for 2 minutes. We have a big cane. If you go over, we're going to pull you off. And you'd be talking about your project. And whatever you want to include in those slides is fine. Screenshots, video demo. Unfortunately, we don't have any way of getting video off the device. So if you want to show any screenshots and video, you have to take those ahead of time and include that in the media that you send to us with your slides. Yeah, so all of that Tuesday evening. And on Wednesday is the final exam. So Thursday is the final exam. March 18th, it's from 12:15 to 3:15 in Hewlett 201. I have no idea where that is, so somebody sees me with a map, you'll know it's me. And if you have any special requests for your ordering in the demo, let us know. If you have some other commitments, or if for some reason you can't make that day, let us know as well, and we'll arrange something else. Another thing to note is we're going to be, and we'll remind you of this later on, we're going to be filming these and posting them online. So if for whatever reason you don't want to be filmed or you don't want your app to be shown to the public, you can let us know ahead of time, and we will make sure that you're not in those. So, all right, today we're going to talk. Yes, yeah.
For final exam, you meant the final presentation.
Final presentation, yeah, it's your exam. What's that?
How many minutes?
2 minutes. Your presentation is 2 minutes. So. Yeah. Sorry to scare you, but yeah. All right. So today, any other questions about final projects? Any outstanding class issues?
How do you demo the application using the Google device?
The question is, how do you demo? And you can't. You have to take videos. We actually well, no. Let's just say no for now. Yeah, you have to take videos. I'm sorry?
No demo.
No demos. It'll be slides only, right? That's what we did last year, I think. Do we do anything with the video camera?
I don't think so.
No. Okay. Yeah. If you have, Anyway, let's say no for now. If you have any really strong need to show video, we can figure something out. Maybe the same mechanism we use in class. Our little hacked up photo booth. Any other questions? Yeah.
How do you show those screenshot animations in which you sort of show the fingers?
Right. So the question is, can you show the animations that happen in the app? What you're going to probably want to do is find one of these screen grab apps online. I don't have any recommendations for you. Some of them cost money, some of them don't. But you're going to want to do a video screen grab of the simulator and then use that.
Is that when you do the presentations?
You're welcome to use those in the presentations. The videos, yeah. I mean, we'll play any video that you embed in your slides, we'll leave as is. Just make sure the files are there when you submit them. So, anybody else? Okay, 2 weeks. All right, so today's topics, we're going to talk about Bonjour, which is, once again, it's a way of doing automatic configuration over the network. So being able to find devices without having to type in IP addresses. And NSStream, those are the first two subjects we're going to cover. We'll get into GameKit a little later, but first these two. Here we go. Bonjour. All right. Bonjour has three main functions, right? The first is it automates address distribution for computers on a network. So if a computer does not have an IP address, this extends the link local service that happens on networks and makes sure that your device has an IP address. It allows you to publish the availability of a service. So if you have some network service, you can broadcast to everybody on your network, or to the world for that matter, that you have this service available to connect to. And it allows discovery of services. So if you have two devices that want to talk to each, or you have two devices, and this one knows that it wants to connect to services, it doesn't need to know that this IP address or this named device supports that service. It can find them, present them to the user, and let the user choose. It's an open protocol, and it was submitted to the IETF, the Internet Engineering Task Force, which is, I guess, kind of like a, I don't know, Team America, World Police, but for the internet. Zero configuration is with the protocol, zeroconf.org if you want to find out more information. So the first thing, well, these are the things that it does. The first is it helps LANs require no configuration. And again, this comes from some of the link local support in the TCP protocol, which is if you have a device on a network that does not have an IP address, it actually goes off and tries different IP addresses and says, hey, is this IP address available? And it waits for a response. If nobody responds, it takes that. If somebody does respond, it'll increment and try a different IP address. So Bonjour helps support that. It will allow you to map names to address without a DNS server. A DNS server, I'm sure many of you know, if you type in stanford.edu, it actually has to hit a server on the network to say, what's the IP address that stanford.edu maps to? And then it goes and requests that IP address as a mapping. So Bonjour does that at a local level, which is very convenient, and a service level, which we'll talk about. And it helps you find services without a directory server. So even though you have the IP address, you don't need to look up another server to find out whether a service is supported. The Bonjour allows these services to be broadcast on the network for easy discovery. So any device can find any other devices as long as it's accessible via a network. Automatic addressing. So this is, again, the extension of the link local. So it tries, let's say you've seen 169.254, I don't remember the number. But when you have a computer with a self-assigned IP address, it's actually picked one out of the sky and says, this is the IP address I'm going to use. And it tries to, with the link local stuff, it'll try and find a unique one. So Bonjour, again, will help with this. But it also assigns a name, right? So there's an idea of a domain, which is kind of the scope of all the computers that you're allowed to connect to. Bonjour will assign a name to your device so you can address it by name instead of by IP address. So if you have a device named iPhone 3G, your device will be iPhone 3G.local. And you may have seen this in Mac OS X. If you try to, if you want to connect to somebody's computer, you don't have to type in their, you hit Apple K, you hit connect to server. You don't have to type in their IP address. You just need to know their machine name. And I can type in josh'scomputer.local, and it should find it. So advertising services. There are different services you might want to provide on a network. A few examples are iTunes home sharing, the remote control protocol, chat. Right? Chat. These are things that you want to find. You have some internet service that you want to tell the world that they can connect to you, but you don't want them to have to know that it's there. They can find you. So the way that these services are advertised is it has a naming convention. And the naming convention, it starts with the service name. So your service name could be, my special chat. Service type. Sorry, service name is the name of your computer. Service type would be the type of service that you're advertising. So let's say you have a service called My Chat. You would have, your name of your computer .mychat .transport protocol, which is either TCP or UDP. The service name is a human-readable description of it's a unique identifier for your machine. So it can be up to 63 characters long. Oftentimes, you'll see like a hexadecimal string. Sometimes you'll actually see the machine name. All characters are allowed. All UTF-8 characters are allowed. And this is what uniquely identifies your name as a service on the network. The service type, which is the second parameter in the service address, is a 14-character service name, which describes the type of service, and it's a string that you choose. And there's some that are already chosen. For example, the iTunes sharing is underscore DAAP, underscore DAP. And there are a few others that it uses. But what you want to do is you want to find a service name that is unique to your application. So if there's 10 versions of your application running, and each of them advertises a service, they'll all have the same service type. But they'll each have a different service name. And the last piece in the address here is the transport protocol name. So the transport protocol name can either be TCP or UDP. There are no other choices. So, yeah. Here's an example. So this is an example of a printer. So a printer is advertising itself using the Internet Printing Protocol. So its name is Canon MP780. Its service type is underscore IPP, which is a pre-agreed upon service type. And the protocol and domain are underscore TCP for the protocol, and domain is .local. Your domain can actually be, I don't think I get into this in the slides, but your domain doesn't have to be local. You can actually advertise on a greater scale if you have something called a Bonjour DNS server. So you can have a service that's advertising itself to the world, as long as all the different pieces, all the different services that you're trying to connect to know about that DNS server. So anyway, the easy case is it's local, and I'll show you an example of that as well. So publishing a service is very easy. NSNet service is the class that wraps the Bonjour mechanism. You create one by saying init with domain, and you can pass in a string here. If you leave it null, it's going to assume, if you leave an empty string, it's going to assume that it's local. You could also pass in local. You could also pass in the DNS server there. But for now, we'll leave it empty. The type is underscore IPP dot underscore TCP. So this is your service name and protocol. Name is the name of your device that uniquely identifies you. And in the case where you're trying to publish a net service, which means you're trying to advertise a service, you pass in a port as well. And the port is whatever port you're using for networking for your service. You would get this by, if you have an HTTP protocol as the backend, you start up an HTTP server, and that HTTP server will have a port for communication. That's the port that you use here. Again, leaving the domain name blank is local. And leaving the name blank, if you pass in an empty string for name here, what you're going to get automatically is it's going to ask the device for its name. And the device's name is whatever the user configured in iTunes when they set up their device. So by default, my phone would be alphone.local. Publishing a service, right? So what we created it in the last slide. The first thing you're going to want to do is set your class up as the delegate for the net service. And the delegate's going to give you a bunch of callbacks. We'll look at those in a moment. But then it's pretty much it. You call publish. And publish starts it up. There are some tools on the web. Actually, there's a great one called Bonjour Browser if you search for, if you want to debug this stuff. As soon as you call publish, as long as you've passed in valid parameters to the init call, that service will now be live on your network, and you can find it with one of these tools. And of course, tearing down, you want to clear your delegate, as we always talk about, right? If you're deallocating yourself, you make sure you're no longer the delegate of any objects. You call stop. Stop says stop publishing. Then you release it and deallocate. Here are some of the delegate methods that you can get back. So the first thing, actually, conflict resolution. Let's say you have a printer, Canon, whatever that was, MP380. If there's already a Canon MP380 on the network, Bonjour will go ahead and, unless you explicitly tell it not to via a property, Bonjour will go ahead and rename that service to something unique. So it could be Canon MP380-1, Canon MP380-2. So there's 3 printers on the network. So that's pretty useful. It just guarantees that your service can be uniquely accessed. And here are some of the delegate methods below. So the first thing is you can get, you'll get called back when the publish is about to begin. You get called back if the publish was successful, and you get called back if there was a problem. And of course, there's as usual, there's an error dict there, or it's often an error. In this case, it's a dictionary, and you can find out more specifics about what actually went wrong. All right, finding a service. So you've gone through, you have one device that's gone ahead and advertised itself, it's published itself to the network. Now you have some other device on the network that wants to find instances of that service to connect to. So for example, I like to go back to remote. With iTunes DJ, right? There's a feature you can turn on in iTunes that basically advertises itself so that any client can come in and request songs for playback. And then any remote, when you launch it up, it goes and says, hey, are there any iTunes DJ services available? And it gives you a list of them, and you pick from them, and then all of a sudden you're connected and you can start requesting songs. That discovery is what we're talking about now. So the ability for the remote to find any iTunes DJ libraries, this is the mechanism that it does that. So the application registers. So when you create a service, you register the service name. But the discovery of the service happens with NSNet service as well. And then you can go and resolve a service to get the actual IP address for doing real communication. One thing I want to note here is that advertising and publishing of a service doesn't actually do the communication. It's only a way of handling the translation and discovery of services to IP addresses. So I'll take you through an example of how this works. And then we'll talk about NS streams, which will help you actually transfer the data back and forth. So when you're looking for services, there's another class called NSNet Service Browser that you create, you instantiate, alloc init, you set yourself up as the delegate, and then you search for services of type, and you pass in the type string. It also takes a domain parameter. You probably guessed that empty string just goes to local, whatever the default domain is. But you can specify something that's bigger, so you can search for, you can search a greater scope. So you start the search by calling search for services of type, and then you'll get a few callbacks here to let you know what it's done. The browsing is all asynchronous, so none of this is going to block main thread. All of this is going to give you a callback when something actually comes up. So let's say I start browsing for services. Of course, I'll get notified when the search is going to begin. I'll get notified when the search is going to end or has already ended. I'll get notified if there's an error. But there are two interesting ones here down at the bottom. The first is did find service and did remove service. So let's say I have, go back to the remote example. I launch remote on an iPhone, and I'm looking for iTunes DJs. Now, somebody on my same network launches iTunes. I can be looking at my remote at that time, and as long as the browse is still happening, which you can let it go indefinitely, then when that iTunes launches, you'll automatically get notified, did find service. You can present a UI to the user with the name of the service, the type, any other information, and it'll be there for me to pick. If the user then goes and quits iTunes, then we'll get a did remove service, and then you can take it out of your UI or disconnect the user because they can't talk to them anymore. So that's your methods for those are your methods for discovery of services. Once you have a service, you don't have the IP address, which means it's not sufficient to talk to that device yet. You only know that that service exists. What you need to do next is you need to resolve the service. And resolving the service is actually it's the mechanism by which Bonjour will translate the name of the service, so Canon MP380, into the IP address that you're going to talk to and port. So once you get a net service back from did find, you set yourself up as the delegate if that's the one that you want to connect to, and then you call resolve. Resolve with timeout, same as resolve, but of course, with the timeout. And you'll get notified when it did or did not occur, right? So if the timeout occurs, you'll get a did not resolve. And if it actually was able to translate the net service into an IP address, you get the net service did resolve address. And it's the same service you get back, but now is populated with IP address and port, so you can go ahead and communicate. And again, once you're resolved, you can go ahead and talk to the service. So let's take a look at that really quick. So I have a real simple example, actually. Let's see, found, was this one? All right, so what I have here is I have an application that as soon as it launches, it advertises itself on the network. At the same time, it presents a table to you, a list to you, of all of the devices that it found on that network. And I have I'll show you on an iPod Touch here, where it's running the exact same application, and it's using, over Wi-Fi, it's going to find the service that we're running a simulator and allow you to connect to it. So let's look at the code. Down in our app delegate, let's actually ignore that receive server. We're going to look at that in a later example today. But all we do, of course, is we take our view controller, we stick it in our window. Nothing special there. But the view controller is actually this guy, found devices table view controller. And let's look at what the implementation here is. When the view comes into, when the view is about to appear, it calls, it creates a browser, it sets itself as a delegate, and it searches for services of sampleservice.tcp. In domain, no string, which means we're going to look for local instances of this service. In view will disappear. We're going to tear it down. Okay. And now down here in the net service browser callbacks, there are 3 different callbacks we've implemented. The first is did find service. Okay. When we find a service, we're going to, we'll create a found services array in case it doesn't already exist, and that's defined in my header. We'll add the net service to the found services list, and then we'll tell the table view to reload. This is a table view controller subclass, by the way. In the did remove service, we're going to take that service out of the found services array, and when we stop the search, we'll just remove all the objects in that array. Down in our table view population, let's look at what we do here. So, of course, every time one is found, we reload. We're going to say number of rows in section is the number of rows in the table, is the number of found services. And cell for row at index path is going to actually create one cell for each found service. So this goes standard stuff here. We create a table view cell. We try to DQ one. If we can't DQ one, we create one. But here we get the net service out of the found services array that corresponds to the index, and all we're going to do is set the text of the cell to match the name of the service that's advertised. Actually, one thing I do need to point out in the receive server, this is where we actually start the Bonjour net service. Right? So this is where we're actually going to do the advertising of the service. So I'll spare you the details of a lot of this stuff. But essentially, so in our app delegate, we created an instance of this object we call start server, which goes down to here. And don't worry about a lot of this stuff. This is standard networking stuff. But the interesting piece is, and none of that stuff is needed, actually, just for the advertising. That's going to come into play a little bit later. But this is where we're actually advertising the net service. So if we were actually able to open a port that we're going to use for communication later, we go ahead and we create our net service with the sample service type, and the name of our service is going to be the name of our device. And the port's going to be whatever port we got back out of the networking code above. If that was successful, we're going to set ourselves as the delegate, and then we're going to publish with options. You can actually just call publish here, and that would actually start up our advertising. So let's see what that does. And just for balance, in our stop server, we call net service stop and clear out the net service. So one class, once again, when we launch the application, it's going to advertise itself as a presence, and then it'll present you a table of all the items it found. So let's just start by running. All right, so there it is. We have an application that found one instance of the service, and it happens to be itself, right? That app came up, it advertised itself, and then it's listing all the ones it could find, including itself. Now, if I run the same application on the phone here, and make sure I'm on the network, what we should see is as soon as this launches, or a fraction of a second after, we should see this device show up in the list. So here I go, I launch. I just tried this like 10 minutes ago. There we go. There we go. So, right, so Alan's iPod, this guy, as soon as it came on the network, it advertised itself via Bonjour. It says, hey, I'm available. And then this guy is still listening. He got or did find net service, and added it to his list and reloaded the table view. So that's it. If I quit this, all I do is quit the app. We should see it go away. Maybe some network lag, but it will go away, I promise you. There is some caching that goes on, so sometimes it takes a little bit. But yeah, it will come off. You saw it come on, so you can believe me that it's going to come off. All right, let's look at the next part, which is how do you actually communicate? So you found the service. Now, how do you actually send data back and forth? It's not really that interesting to just have a list of services available. You want to actually do something with that. So let's get back to where we were. So we're going to talk about NSStreams. All right, NSStreams is a convenience class that wraps sockets. Right, so for those of you that are familiar with networking code, sockets are a way for two processes to talk to each other, whether they be on the same machine or on different machines, and they communicate via a port. We're going to use NSStreams as a way of doing this, which are conveniently very well supported in NSNet service. So if you can actually ask for an input stream and an output stream from your NSNet service. So this is it. Right? You have two variables, input stream and output stream. When you got a net service, when you received a net service and you successfully resolved that net service, which means you got an IP address, you can go ahead and get the input and output streams so that you can send data back and forth. It's a lot like sockets. It's a little higher level. The changes are asynchronous, once again, so you set yourself up as the delegate on the stream, and it will call you back with, there's only one method it calls you back with. Writes are still synchronous. Sorry, state changes are asynchronous. So the coming and going of connections is asynchronous. The writing and reading is actually synchronous in this case. You can have several streams, and they're used for different things. You can use them for writing the files. You can use them for network activity. They are, so NSStream is a subclass of NSObject. And there are two subclasses there that we care about. One is NS input stream. One is NS output stream, as you can probably guess. NS input stream is useful for getting data from another process. NS output stream is for sending data to another process. When you open a stream, all right, so in our case, we're going to get the stream from the Bonjour net service. You set yourself up as the delegate. And then you call this method called schedule in run loop. And you may have seen this with other objects as well. And I'll talk about run loops in a second. But you need to schedule your stream in a run loop so that you can get events from it, so that it can read from it, write to it, and so that you can get callbacks about it. So once you've scheduled in the run loop, you call open, and that actually initiates the connection and starts data transfer. Closing a stream is just the opposite. You close it, then you take it out of the run loop, and you clear the delegate. So what's a run loop? Well, we've already talked about run loops in terms of touch event processing. So when your application is running, there's this loop that basically sits there and goes, do I have anything to do? Do I have anything to do? Do I have anything to do? And when something actually is scheduled and ready to happen, in the case we've talked about already, it's a touch input. Then it goes and dispatches to you, to your targets or to your notifications to tell you that something happened. This is actually the same mechanism. So when you schedule a stream in a run loop, you're basically saying, I want this run loop to check the stream for input or to write data to output. Also, it's the same mechanism used for timers. So when you schedule a timer in a run loop, every time the run loop runs, it says, does this timer need to do anything? Does this timer need to do anything? At some time, the timer will say, hey, I need you to call this selector, and it goes and does that. So the NSStream events are actually processed in the run loop. That's why you need to call that schedule in run loop. So you'll notice there's actually another parameter here, which is schedule in run loop for mode. And oftentimes, most of your cases, in fact, I don't know if I've ever had to create my own mode, but it is useful sometimes. But we're going to pass in NS run loop common modes, and there are a few different scopes of what kind of events should get processed. So if we look here, there's actually an example down at the bottom, UI tracking run loop mode. You may actually want to, in the UI tracking event run loop mode, that's the kind of case where you want to track somebody's finger really closely. So the system will go ahead and it schedules certain things to not run in that run loop mode. Don't need to worry about that for now. For most of the work you're going to do, or most of the work you're going to run into, you're going to just pass in common modes. All right, so your delegate calls from NSStream. There is only one. There's stream handle event. Stream passes you the stream that you're a delegate for, and handle event is an enum of different kind of actions that have occurred, different events that have occurred. You can get notified when the open of your stream is completed. You can get notified when there is space available. You can get notified when there's an error. You can get notified when it closed. You can also get notified when, why is that not in there? There's also stream events for data did become available, data did read, and yeah, that's how you actually get data in. So when you get a NSStream event, data did become available, I think it's called, you actually read from the stream, and you can get whatever bytes are sitting there waiting for you to process. So here's a case where we're going to do the output stream. So if you got an output stream from Bonjour and you want to send data over that output stream to the other side, you call write with a buffer and max length with the size of the data that you want to send in bytes. So here's a case where we want to send this hello world string over the network connection. We're going to call write. So we put that into a buffer. We call write with the buffer and then with the length of the buffer. And if there's, for some reason we didn't write the number of bytes we thought we were going to, then we throw an exception. Bless you. So here's our input stream example. When you get one of these NSStream event, data available, bytes available, whatever it is, you take your input stream you call read, and you pass in a buffer that's the right size with max length. Right? So you don't actually know how big. I think you can ask the stream how much data is sitting there waiting for it. You can allocate the right size. But let's say you've got some fixed size buffer. You can read, let's say, 1024 bytes. You pass in an alloc buffer of 1024 bytes. You say, the maximum you can put into this buffer is 1024. And it will call you back with the number of bytes that it actually read. So here's an example. So we create a buffer of 1024. We call read max length 1024 minus 1. And what we get back is what came in off the input stream. So let's take a look at how we're going to use Bonjour to do that. I hand waved a little bit earlier when I said we're not going to look at the transfer of data. And I'm going to hand wave a little bit now, but I'm going to post this code on the website. In this start server call that we had before, that we looked at before down at the bottom, right up above it, we're actually creating a network port. And again, I'll spare you the details. That's not really important right now. You can look at the example code. But we're basically creating a socket for network communication, and we're getting a port off of it. And that's what we pass down to Bonjour. That socket is used for reading data off the network. That's how we set things up before we advertise for Bonjour, so that there's something there listening for data. Now, where the input and output streams come in useful is once we made a connection. So down in our found devices table view controller, right, the table view that lists out all of the different services that it found, there are a couple more functions down here that say, standard table view, did select row at index path. What it does in that case, because you can't read from a stream that you don't have an IP address for, the first thing it does is it gets the net service from the array, sets itself as the delegate, and then resolves. Right? So resolve is the action of getting the IP address for a service. When we get the net service did resolve address, which is a delegate method for the net service, we're going to create a message sender UI view controller, and we're going to set the net service to be the one that we just resolved. And then we'll push it onto our stack. Now in our message sender, really quick, the nib here is one text field. It's just a text field for input. All right, so here it is. And we're going to use it to send text messages back and forth via Bonjour. So let's look at the message sender. Again, pretty simple implementation here. It has a net service because we set it before we pushed it. When view will appear gets called, it gets the output stream. All right, so we're only going to use this to send messages to the Bonjour service that we're connecting to. It gets the output stream. It sets itself as the delegate. It schedules in the run loop, and then it opens that stream. And then, of course, when we're going away, we'll tear that down. And then this is pretty much the meat of how we're sending the data. When we get a text field should return. So when I hit return on that text field, we get this delegate method because we're, again, the delegate for that text field. We're going to create an NS data that basically contains the text from the text field. So whatever I type is going to get packaged up as NS data. And then we're going to write those bytes to the output stream that we got back when we got pushed onto the stack. Right? So again, the process is you select an item in the NSNet service list. It's going to resolve that to get an IP address. It's going to push this text field onto the stack, onto the view stack. And anything you type will get packaged up and sent to the other end. And then, again, a little hand waving here, but when the server here is actually going to be listening for that data. Here we get a did receive data callback from the server down below. We unpack the string from that NS data, and we're just going to throw up an alert that says, the title is message, the message is the string, and then put an OK button. And then we'll show that alert. So let's do that quick. All right, so of course, it only sees simulator right now. Let me launch the app on my phone, on my iPod Touch. There's this network delay, but it will show up. Only when I'm about to give up will it actually show up, because that's just how it works. There it is. And of course, the simulator showed up in here as well, right? So what you see, really quick, what you see on the simulator is it found the simulator first, and then it found my iPod. But if I look on the device, the first thing it did was it found my iPod, which is the local Bonjour service, and then it found the simulator. So I'm going to click on the simulator here. Come on. Right, which means I'm resolving to the simulator. I'm getting the IP address for the simulator. And now whatever I type should show up as an alert on the simulator. So I'm going to type hello CS 193P. I'm going to hit return. It's going to package up the data, send it, And on the other end, we get a message that says, hello, CS193P. I can say, you know, star. And it's going to package up this text and show up in the simulator. Similarly, because both sides are advertising, I can click through to Alan's iPod, which is this guy, and I can type in, you know, sup. Ooh, it auto-corrected. All right, support fool. And then when I hit return on the simulator, we'll get the message passed to the iPod. There it is, support fool. That means nothing. All right, so that's NSStream's pretty simple stuff. Again, the service, the actual HTTP server or UDP server, I think, sorry, this was a TCP server, a socket server, is up to you to implement. Bonjour doesn't do that for you. It will only facilitate the discovery and connection to services that already exist. So that is NSStreams. Now, okay, a new technology that that came out with iPhone 3.0, which I think is totally cool, is called GameKit. And all of this network connectivity and Bonjour advertising, a lot of people, you know, just want to use this to connect one device to another, right? You're writing some multiplayer game, you're doing air hockey, and you want to play against somebody else who's on the iPhone, and you don't want to, you know, maybe you don't want to write all this networking code. Well, this abstracts a lot of that stuff away from you. It also provides a UI so that you can pick users, pick peers that it finds on the network. So here's what it does: peer-to-peer connectivity, abstracts away Bonjour and the streams. It allows you to do it via Bluetooth, and it allows you to do it via Wi-Fi. The Wi-Fi stuff's a little more complex, but we're going to talk about Bluetooth in depth today. And it also provides in-game voice transfer. So you can do voice, you know, let's say you're doing some multiplayer game, you guys are on the multiplayer shoot 'em up, and you're on the same team, and you're like, hey, shoot that guy, and you know, it's coming up behind you, watch out. This will actually send the voice data back and forth. And it will actually manage the volume too, so if you've got crazy explosion sounds that are going on and your buddy's trying to talk to you, it'll actually pull down the other volumes so that you can hear your friend on the other end. So here are there are only three classes in GameKit. There's the GK Peer Picker controller, which is provides the UI for picking your peers. And it facilitates the creation of a GK session. The GK session is actually what does discovery of peers and connection to peers. And it's also what allows you to send data back and forth between peers. And then the last one, which we're not going to really touch on today, is the GK voice chat service, which allows you to send audio back and forth, right? So primarily off the microphone, but you connect the two together, and then you can speak back and forth with very little code. Right? Normally you'd have to do, you know, audio compression. You'd have to like build an audio chain, build an audio session, sorry. You get the voice data, you'd have to compress it yourself, send that over the wire, decompress it, build another audio queue that takes it in. There's none of that. There's like 2 delegate callbacks and a couple of properties you can set. So, all right, so GK session. This is where you're actually going to do the meat of your data transfer. So you create it by doing init with session ID. Session ID is essentially it's your service name that we talked about in Bonjour. It's a way for your application to advertise itself as unique to other applications. You pass in a display name, and the display name is the local device name. So it could be whatever you want actually, but it's what specifically identifies your device versus your peers. And a session mode. And there are 3 types of session modes. There's a server, a client, and a peer. So if you're doing a multiplayer game, maybe you don't want to have one side be the server and one side be the client. You just want them to be peers of each other. It's a little more dynamic that way. You don't have to create that stuff. It creates it for you. But if you have a server that you're always connecting to, you can specify it as the server, etc. and servers can't connect to servers, clients can't connect to clients, right? Stuff like that. GK session is, again, it's actually a little more complex than this, but there are a few properties that we really care about here. One is the display name, which is your name as seen by your peers. There's the peer ID, which is your ID, your unique ID that distinguishes yourself from your peers. So, there could be two people on the same network with the display name Bob, but one of them is going to be, Bob's iPod Touch 123, and the other one's going to be Bob's iPhone 456. And a session ID, again, is the service that your application is advertising. You don't need to do the protocol and domain stuff that we saw in Bonjour. In this case, it's just a string. So if you're building my shoot 'em up, your session ID can be called my shoot 'em up. A few delegate methods you can get back from a GK session. So once again, you can set yourself up as the delegate. You can get notified when your peer's state has changed, when he's coming and going. You can get notified of connection requests. So if somebody tries to connect to you, you get a delegate call back for that, and you can accept or deny. And you can get notified, of course, just like all these other delegate methods, when there's an error for connection or for data transfer, stuff like that. If you want to send data and receive data, right? None of this setup of NS streams, none of this server that I wouldn't even show you because it was too complex. All you do is you call these methods once you're connected, right? So the GK session manages connection for you. There are just three data methods we're talking about here. One is send data to peers, which lets you send an array of the peers that you're sending to. So if you're connected to 5 people and you only want to send a message to 2 of them, you pass in that array here. With data mode, GK send data mode, there's 2 data modes. One is, there may be 3, but the data modes are reliable and unreliable. So basically, you can send the data reliably, which means that if for some reason there's a network connection failure, it will retry. If you send it unreliably, it's just going to bulk broadcast or bulk send that data. And if for some reason it gets dropped on the floor, it doesn't really matter. And you can kind of imagine when those two are important, right? So if there's state information that you need to maintain between the two, it better be reliable. If there's like a stream of data that you're generating pretty rapidly on one end that you don't need everything to get to the other end, you can let it be unreliable. And I'll show you an example with unreliable. The second data method here is send data to all peers, right? So one method broadcasts to everybody. And same, both of these take an NS data. Both of them have the GK send data mode. The only difference is that one is to everybody, one is to just a few. And the last one's a delegate method. So we set ourselves up as the delegate for the GK session. And then we implement receive data from peer. And the peer is just an NS string identifying the peer. In session, you get the session back that you're a delegate for. And context, you can set a context on the delegate, so if you have some object you want to keep track of. But that's it, actually. That's it. That's sending data. And I'll show you that again in a minute. Now, the GK peer picker controller. So this is what actually puts up a UI and prompts the user to select another phone. So again, you don't even have to implement the Bonjour discovery. You just say GK peer picker, and you can say, I want it to be online, which is Wi-Fi, nearby, which is Bluetooth, or both. And it'll allow the user to pick one or the other. If you do the Bluetooth, if you do nearby, it's really simple. Like there's very little to do. It's all that stuff's abstracted for you. If you do online, then it doesn't do a lot of the things that Bluetooth does. It actually hands off responsibility to you as an application to connect to the server, build a server if you need to, stuff like that. So we're going to look at the nearby one. And just to be clear, the online one can either be, Wi-Fi on a local network where maybe there's no server, and maybe it's not server clients, maybe it's still peer-to-peer, or it can be, a server in the sky and a bunch of clients that connect to it. All right, when you create a connection, so you want to find your peers. You create a GK peer picker controller. You set yourself as the delegate. You tell it what kinds of types you want, right? Online and nearby, and then you show. That's it. All right, a UI, a canned UI is going to pop up for you. It's going to allow the user to pick, online or nearby. It's going to allow the user to pick which device it finds. And then it will prompt you to connect. So there's when the user initiates the session, so if I say, when a user creates the peer picker controller, if you go to say, I want it to be nearby, and the user picks nearby, it's going to ask you for a GK session, which you're going to allocate and pass back. Then the user is going to be prompted with the list of devices that are available of all the sessions that it finds, and it will call did receive connection request from peer. Boop. Then it's up to you. So when you get a connection request from a peer, it's up to you to accept that connection or deny that connection. I'm going to show you the accept connection case in just a sec. But this is actually what sets you up. So once you've accepted the connection, your GK session can go ahead and start sending data back and forth. And you can accept connections from 10 different friends. You can accept connections from one different friend. You can deny everybody if you're, miser. But that's it. It's really simple. So, well, actually, let's look at a demo. All right. So one little nuance about the GameKit stuff is, unfortunately, you can't do simulator to device. So when you want to test this, you actually have to do device to device or simulator to simulator. So you can run two simulators and have them do GameKit transfer, or you can run two devices and allow them to do GameKit transfer. We're going to do two devices today. Nothing special about the two. It's just that they can't cross-pollinate. So, all right, real simple here, right? So we're going to, this is our app delegate. We're going to create this communal touchboard screen with this view controller, and we're going to add it to our window, right? Nothing special there. And here is our view controller. Okay, what we're going to do in our view controller is, let's give ourselves more space here. All right. Let's look at the nib really quick. So it's just a blank screen with an info button down at the bottom. When I click that info button, I'm going to create a GK peer picker controller that will prompt me to choose another device. But this whole view is basically a touchpad. So whenever I put my thumb down, it's going to draw a red square where my thumb is. If I'm connected via a session to another device, it's going to send that touch data unreliably to another device. And the other device will paint my thumb location wherever, if device A, wherever my finger is on device A, device B will show that finger location, and vice versa. So before I show you the network stuff, let's look at the unnetworked implementation of it. All right, so here is my screen, nothing simple. I've got that little info button down the bottom. You can kind of see as I move my finger, I have a red square being drawn underneath. And when I let go, it's going to go away. It's hard to see because my finger's there, but if I had smaller fingers, it would be easier. But there it is. Now what happens is when I hit this info button, come on. There, we get a GameKit picker screen that comes up. And it's backwards, but basically it gives you two options. One is online and one is nearby. Before I get into that, let me show you what's on the back end. All right, so there's a bunch of processing here for doing the view drawing. Nothing really special. It's just keeping track of what points there are, and then it draws little red squares wherever the points are. And the view will appear, and view did appear. There's nothing really special there, except that we're saving off the device name to be our local username. Again, just more code here for doing touch tracking. I have a touches for user, so we can tell the difference between touches that are local, touches from another user. In fact, there could be 10 users. We can still tell the difference. Some methods for keeping track of those. All this will be on the website, of course. We'll look at this send local touches in a little bit. But here's basically what happens. We have 4 touch methods, right? These are standard UI responder touch methods. Touches began, touches moved, touches ended, and touches canceled. So it takes the touches. In this case, we're actually only taking the first touch. We're going to convert it into a touch value. And touch value is just my wrapper for the touch. We can't actually pass the UI touch around. So this thing goes and it stores the point. And we add it to our touch value array. And we tell the view to update. And this is true for all of these methods. We tell the view to update. And then we call send local touches, which actually sends the data over the network. So before we go into that, let's look at how the GameKit peer picker controller is set up when I press that info button. So that info button is actually going to call through to find peers. Okay? Find peers, all it does is it creates a peer picker, alloc init, sets ourselves as the delegate, and says that we want to either allow online or nearby. And then we call show. Right? Show actually puts that alert on the screen for the user. We won't get a callback until another user tries to, actually, no, we'll get a callback when the user is prompted with nearby or online. When I say nearby, we're going to get a delegate callback, which is session for connection type. And this is where we go ahead and we create our GK session. Once again, GK session is what actually handles the data transfer. So we create a GK session. I'm passing nil for the session ID. I don't know why I did that. But anyway, pass the username, the local name as the display name. And the session mode is going to be peer. All right, so that basically advertises the world at this point that there's a session available. There are a couple other methods here. So there's the did connect peer. Actually, you'll notice, so when the user picks a selection type, so if I pick online versus nearby, in the online case, that's where I would have to actually go and build a server or connect to some server in the sky. So for now, we're just going to dismiss the picker if I do that. But in the nearby case, I don't have to do anything. Like, it does it all for me. The session that I return from up here is our session for communication. All right, so the user has picked that they want nearby. They want to find other peers that are nearby on Bluetooth. They're presented with a list of other devices that are available. And when they pick one, they'll get called here. Peer picker controller, did connect peer to session. We get the session. We set ourselves the delegate. We set ourselves as the data receive handler. All right, the data receive handler is what actually allows us to get that receive data method callback. And we're going to store off the session just for good measure. I don't know why I'm doing this either, but basically I'm just sending an empty array to say that I don't have any touch information. And then we dismiss the picker and we auto-release. So now, okay, so that's the connection side of it. Stop me if I'm getting too, if I'm piling on too much in one go. I want to look at the data sending and I want to look at the data receiving, which are the last pieces of this. Again, whenever somebody touches down in my view controller, I'm going to call send local touches. All right, send local touches is going to get an array of touches that we've saved off with every time we've done touches began, touches moved, touches ended. And we're going to archive that array to be sent. NSData, data. And here it is, game session, our local session. We're going to send the data to all of our peers. So everybody that's connected is going to get our local touch data. Data mode is unreliable. I don't care if some of these get dropped, right? It might get dropped because there's too much network activity. It might get dropped because there's an error in the transfer, whatever. That's the sending of the data, right? So the same code is running on a second device, which is actually going to receive the data. So where did I implement that? Receive. Down at the bottom here. Receive data from peer in session. We get the value. We get the array back out of the archived data. And we set that into our touch values, and then we tell the view to redraw. All right, so That's a lot of stuff to digest, but basically, we're going to input touch information here. It's going to come over here. We're going to input touch information over here. It's going to arrive over here. And both of them are going to draw on both sides. Okay. There's actually another method that's glaring in front of us that we needed, which is the did receive connection request from peer. So when somebody actually tried to connect to us, we have the opportunity at that point to accept the connection or to deny the connection. We're going to accept it. So let's go back to our photo booth. And let's see how this works. All right, here's device 1. Once again, if I mouse around, if I touch around, there's a little red box that follows. All right. And here's device 2. Oh. When I mouse around, it's going to be hard to hold these. Okay, this is 1. Left hand is 1. Right hand is 2. This is right hand. When I mouse around, little square follows. We're not connected, of course, right? So let's just do one device at a time. I'm going to click our little info button, which should pull up the game picker controller. My button's really small. There it is. All right, so our options are nearby and online. I'm going to say nearby. All right, now it's looking, right? It says looking for other iPhones or iPod touches. So it's looking, it's looking. This guy, I need to do the same. So we're going to press the button. All right, and we're going to say nearby. Now they're both looking for each other. They're both looking for some peers that it can find. All right, look, they both found each other. So now I'm going to pick one. So the iPod Touch, I'm going to say I want Alphone. And now on the Alphone, we'll get a confirmation dialog. One sec. Do you want to accept the connection from whatever Alan's iPod would like to connect? We're going to say accept. All right, so now when I mouse around on the iPod Touch, we should see my mouse movements show up on the iPhone. And similarly, right, when I move around on the iPhone, look, there's the mouse movement on the iPod Touch. And the way I've written the code, again, is, you can go look if you want, but I've actually got both those sending. So if I look at the two, there's 2 squares going, one for each side. It's hard to hold, but that's it. All right, so that's GameKit. That's sending data. You can send whatever data you want, right? I'm sending a bunch of CG floats that are compressed into some NS data. You can send any objects you want. In fact, if you want to just take your data model and send that back and forth, take a look at the NS coding protocol. We've talked about it, I think, briefly early in the past, but there's a way for any one of your implementations of an object to easily be archivable into an NS data. And then you can send that back and forth, and now you can send whatever objects you want back and forth. So that is GameKit. Woo! Oh no, did it disconnected? Anyway, that's GameKit. Really simple, allows you to do some pretty powerful server-client stuff or peer-to-peer stuff without much work on your end. Take a look at the sample code, and that should help. The Bonjour stuff, once again, you'll actually see that in a lot of places. It's not just an Apple thing. It's proliferated everywhere. I think your TiVo advertises itself. There's all kinds of servers. A lot of printers these days have them as well. So that's really useful. But yeah, that's networking.
For more, please visit us at stanford.edu.